Hi, my name is Robert Walkine, and this is my podcast on the fundamentals of physics in Brazilian Jiu Jitsu. Now, if you're unfamiliar with Brazilian Jiu Jitsu, don't worry, there will be a link showing you a highlight video of this phenomenal sport. In this podcast, I will be examining the stand up part of the sport, which is commonly known as takedowns, in which you use a technique or a throw to take your opponent down to the ground so you can either continue or finish the fight. But before I get into the physics of all of these phenomenal takedowns, here's a small clip showing you an example of some.
Go.
Basic hipótese lagi. Drop sale.
Was a trainer for the future? Was he a
Drop. The pro.
Come on, Brian, cheer up.
Okay, pause it for a second.
Did you enjoy that? I know I did. Now we're getting into the nitty gritty of it all, the physics. And before I can show an example of physics being applied in Brazilian Jiu Jitsu, I have to define a few definitions and laws so we can know exactly what's going on. The first law or definition that we must know in physics is inertia. And inertia is defined as the tendency of a moving body to keep moving is natural. Every material object resists change in its state of motion. This property of things to resist change is called inertia. Static friction is the force that resists the initiation of sliding motion of one body over the other with which it is in contact. That is, the force required to move one of the bodies when they are both at rest, also known as limiting friction or starting friction.
And that is it.
All right, I think we're ready. And here to help me explain the first clip is my physics teacher who will explain the transfer of potential energy to kinetic energy.
All right, so when you're lifted to the highest point, when he's lifted you and you're at your stopped point up top, that's the highest potential energy because the height is the greatest, and we know potential energy is mass times gravity times height. So if your height's higher, your potential energy is going to be higher. So once you're dropped, you're accelerating towards the Earth at the speed, the acceleration of gravity. So that goes downward at 10 meters per second. So you're picking up speed, which means your kinetic energy is going up, but your potential energy is going down because your height is lowering as you go down. And then right before you hit the ground, you're moving at your fastest, and your potential energy is almost at zero. So the potential energy at the top equals the kinetic energy at the bottom.
Oh, okay.
Sir Isaac Newton's second law of motion, which states the acceleration produced by a net force on an object is directly proportional to the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. The conservation of momentum. The conservation of momentum states that within some problem domain, the amount of momentum remains constant. Momentum is neither created nor destroyed, but only changed through the action of forces as described by Newton's law of motion.
Grab that. Don't let go of that, Kevin. You have it. You have it. Watch out. He's going to try to roll you. Good. Don't roll.
Oh!
I told you he was going to roll you.
The 7.
And there you have it. Just a handful of some of the physics we see in Brazilian Jiu Jitsu. I hope you enjoyed watching this podcast. I know I enjoyed making it. And if you're interested in seeing more physics, I recommend watching a few clips from the popular show Human Weapon, in which they break down the mechanics and physics of not just Brazilian Jiu-Jitsu, but other martial arts as well, and examine how effective they are and the science behind it all. Again, I thank you for watching this video, and I hope you learned something. I know I did. But before I go, I leave you with this brief video showing you how all of the physics that we learned today is put together in a brief sparring match. Enjoy.
Robert Baker. I think you remember.
A little bit more.
Is that it?
One of us. Gotta go down. One more good threat.
I'm just telling you right now. Not everybody does it. Okay? Here, whoa.
And cut.
Now, physics ain't involved in that.